Hello, everyone. Welcome to another exciting meetup today. I am Hayrettin and organizer of the JAK Istanbul meetups. I will be hosting this meetup with my colleague Özlem, and also Altu will help us if there is a technical issues. Before moving to presentation, I'd like to give you a brief introduction to our user group. JAK Istanbul is one of the biggest software engineering community in Turkey, and we organize meetups, hackathons, and code retreat organizations and regularly. And we organize our well-known annual international conference, Java Day Istanbul. We are scheduling next year's Java Day Istanbul, by the way, and keep updated. And we are constantly discussing how to grow Java ecosystem in Turkey. Therefore, I highly encourage you to join our Slack channel in order to share your experience or ask some questions. And we are more than 1,000 members, and we host more than 100 events, and we are proud of giving contribution to Java community process and Eclipse Foundation. And our upcoming events will be in 4 September. We will be hosting a bootcamp with the ING Bank. And on 29 September, we will have a workshop with Sven Robert. It will be about DevSecOps subject. And in 13 November, we will have global dev code retreats, and stay tuned for the news. And about ING Agile Developer Bootcamp, it will be with the collaboration with our user group, and we want to grow ourselves in the agile development methodologies. And if you haven't heard about it, I strongly recommend our podcast, which you can both stream in Spotify and iTunes, and you can find very good topics by amazing speakers. And it is regularly we are making podcasts. We try to make it in 2 times in a month, and also if you we are time to time we promote some discount codes for from JetBrains, and stay tuned with following our Twitter address, and we time to time promote some discount codes from JetBrains. And our thanks to our sponsors, Definex, JBrook, Hazelcast, GoToWebinar, JetBrains, and Mural. And with their help, we can host these presentations. And also, as I said, don't forget to join our Slack channel. We are discussing many topics and promoting our meetups also. If you want to find out more, you can always email us or send us some message from Twitter. And thank you so much. Today, Steve will be us, and he will talk about Jakarta Concurrency project and how to contribute on that. It is really exciting topic, and I give the presentation to Steve. Yes.
Okay, thanks. Yeah. Thanks for inviting me. I'll just share hopefully the correct screen. Okay, can you see that?
Yeah, we can see.
Cool. So thanks for inviting me. It sounds like an exciting user group. So I've been invited really to talk about Jakarta Concurrency, its present, its future, and how you can contribute. I think the idea was that as part of a doc specification from user groups that we would go out as sort of project lead for Jakarta Concurrency and solicit help to shape the future of one of these key Jakarta specifications. So I'm Steve Millidge. I'm basically the founder of Payara. Payara is an open source application server which implements Jakarta EE, but also implements MicroProfile. So in this talk, I'm basically going to cover 4 things. I'm going to cover why do we need Jakarta Concurrency? What is its goal? Then we look at what are the main components of the specification. We'll look at futures around the specification, and we'll also then talk about how to get involved. Okay. So first topic is really going to be, I'm going to do a recap of a little bit about Java EE and Java EE history, and where Jakarta Concurrency fits into this. And I'll also recap about the transition from Java EE from Sun and Oracle into the Eclipse Foundation, just really to set some context of where this is. So Java EE obviously has a very long history. It started in 1999, so we're talking maybe 22 years ago, 21 years ago, and it's had many releases. I mean, Java EE 5 was obviously a major release where the whole of the platform sort of moved to annotations as opposed to from XML, and was modernized substantially. And then as we move forward, the other thing to note really is the transition to Eclipse Foundation. So that occurred around getting close to 2 years ago. We could talk a little bit about what happened there because it's sort of important for Jakarta Concurrency. So Java EE 8 was released in 2017. Java EE 8 was the last release that was done under the JCP, the Java Community Process. And it was decided sometime around probably the following year, early 2018, that Java EE needed to move to a sort of a new governance model and needed to move to an independent open source foundation. And the Eclipse Foundation was chosen as the sort of steward of the Jakarta EE going forward, Java EE going forward. And the name was changed obviously because Java is a copyright trademark of Oracle. The name had to change to become Jakarta. And Jakarta was chosen as it has a long history, within the Java community as a name associated with Java. So there has been 3 releases under the Eclipse Foundation, and these are quite carefully constructed. So I'll just talk through these. So first, Jakarta EE 8 was exactly identical to Java EE 8. This was so that the Eclipse Foundation could release a binary compatible version of Java EE 8, but under their own processes, with the same API, the same namespace, the same test suites and things, which I'll talk about later, just to show that the biggest change really was the licensing and governance of the process. So Jakarta EE 8 is released binary compatible with Java EE 8, but under a much more liberal licensing and intellectual property rules, and through an open source, open process. Then came Jakarta EE 9, and the biggest change here is it is identical to Jakarta EE 8, except the namespace changes from JAVX, which is a Oracle trademark, to Jakarta, which aligns with the new name for Jakarta EE. Other than that, everything is identical. So functionally, it's an identical piece of software functionally, but it's just under different IP, different namespace. And then there was an update, a minor update released in May this year, which basically brought all the test suites up to JDK 11. So everything can run now at JDK 11, and then that sets us forward and sets us up for JDK 17, which will come out in September. So this was quite a long process. It basically took about 2 years, 2 to 3 years to work this through. But now where we are at this point in time is that work on Jakarta EE 10 has started, and this is where this is relevant to this talk in Jakarta Concurrency. Jakarta EE 10 will probably come out sometime early next year. And now where we are as a community is we can move forward all this, what was Java EE technology in a completely open source, open license and open source way of development. So no more expert groups, no more closed groups that you need to apply to contribute. So that sort of sets the sort of context. I mean, Jakarta EE didn't stall at this time because something I won't talk about too much, but basically the MicroProfile initiative kicked off, and that sort of built a whole bunch of APIs on top of Jakarta, which sort of carried on innovation, and now both of those API groups are in the Eclipse Foundation. So moving back onto Jakarta Concurrency. So what is it? So it was introduced in Java EE 7, and its full name when it was introduced as a JSR was Concurrency Utilities for Java EE. It hasn't changed it didn't change in Java EE 8, it hasn't changed in Jakarta EE 8, and the only thing that happened in Jakarta EE 9 is the namespace change, as I mentioned. So there are new Maven coordinates for it, but if you use full platform as your API dependency, then you will get Jakarta Concurrency. So what is the goal of Jakarta Concurrency? And this is actually pulled from the specification, so I'm not going to write bullet points in full sentences like this. So basically, and in its simplest form, it's to provide an API that is very similar to the same API that is in Java SE. So managed executors, scheduled executor services, managed threads. So it's basically bringing those APIs, building on top of them, and allowing you to use them within Java EE applications or Java EE runtimes. And basically the reason for that, and again, I'll set some context, is when you're talking about Java EE or an application server runtime, what do we mean? So for something like Payara, for example, Payara provides a lot of services to your application. So you build an application just using Jakarta EE, Java EE APIs. You then package that up into a WAR file, and then you deploy it to an application server or an application runtime like Payara Micro or something like that. And what Payara does, or any Jakarta EE application server does, is it provides a whole load of services to your application. One of the key ones is security. So you can define security constraints on the services, and the application server or the runtime manages that security for you and does the login and propagates that security throughout your application, so you can do is user enroll or make calls like that. It also obviously manages databases, it manages the HTTP server, it manages threading, which is another key thing. It basically does a lot of resource management for you, so you don't have to when you're writing an application. And that's where it comes a problem if you were just going to use the standard Java SE APIs. So for example, if you had a servlet and you wish to spawn a thread, then if you just use the standard Java SE APIs to create a thread, then you're going to lose a lot of the context that the application server provides. If you go into the implementation of one of these runtimes, a lot of things are stored in thread locals. For example, your security principles will be stored somewhere on a thread local, so it can be propagated to different components of your application without you having to do any work. So if you just spawn a thread in your Jakarta EE component, like a servlet or a REST endpoint, then you're going to lose a lot of that context. So Jakarta EE concurrency really is solving that problem. It's basically enabling you to use standard concurrency type APIs, but retain the context of where you are in the application server. So why was it introduced? So let's look at what that means, typically for your application. What is the use case of using Jakarta concurrency? So the first one is add an asynchronous break into your application. So before Jakarta concurrency came along, and I spent a lot of years as a consultant in the field talking to organizations about building Jakarta EE applications, and many older applications do this. So if you wanted to do is basically have a request to a servlet or a REST endpoint, doesn't really matter, and then you wanted to kick off some long-running job, because you weren't allowed to spawn threads, or you shouldn't spawn threads, then what a lot of people did was they would push a message onto a JMS queue, Then they'd have an MDB that would pick up the message, and it would do some long-running action. For example, if you wanted to, I don't know, do a long query or something for somebody, and then you would push the results back down the HTTP request. And a lot of old applications do this, but it's a massive heavyweight thing to do, to have a JMS broker just to really spawn another thread. So with Jakarta Concurrency, that changes. So as I say, it came in Java 7, so it's been around quite a long time, but a lot of people aren't aware of it. So in Jakarta Concurrencies, what you would do, you would take a request. You can use a managed executor service, exactly the same as you would maybe do if it was in Java SE. You can kick off a long-running action, and that would run on a separate thread. And this is obviously a lot more lightweight than embedding a JMS broker into your application and using message queues to achieve exactly what you want. And Jakarta Concurrency effectively creates the API if you're allowed to do this, at the same time carrying all that context. For example, if this was a REST call that required a user to be in a certain role or to be logged in and authenticated, then what Jakarta Concurrency does is it will propagate that security principles across into the next thread, so you can still use security primitives and authorization in the second task. So what does that look like in code? So basically, this is how you would do that with using Jakarta Concurrency. You basically, because we provide as Payara or any application server that provides a default executor service, you would inject it into your REST endpoint, and then when you in your GET request, you could basically just submit a job, just like you would do if you were just using Java SE primitives. And that's it. So that is way simpler than injecting a JMS resource, creating a JMS session, connection, producer, and then submitting a JMS message and building an MDB to listen to that message. It just follows exactly the same as a Java SE API, but provides you all that context that you would need in the actual job that you're running. So that's a very simple use case. Now you can do some of this. There have been other APIs have developed their own asynchronous annotations to achieve something like that. For example, Servlet has its async, and so does REST, and so do EGBs, but all of them are not built on top of this API, which I'll come to later. So another use case is to run tasks in parallel. Now this would be exceptionally complicated before Jakarta Concurrency in a Java EE world. So for example, say you have a REST request come in, you need to submit 2 jobs in parallel, and then you want to join back with those jobs to provide some result back to the requester. If you did that before Jakarta Concurrency, that would be actually quite difficult to do. So especially in the context, in a security context, as I mentioned. If you were doing it with JMS, then you would have to submit 2 JMS messages, build 2 MDBs. You probably have to use correlation IDs, message filters to make sure you can get the 2 messages back, and that they are the same responses to your requests, and then merge that with another MDB that could then call back into the REST. So it would be exceptionally complex to do. And in using Jakarta Concurrency, it's actually very simple. It's exactly the same as you'd expect to do it using Java SE, as I said before. So, for example, here's your request. So, using the managed executors that we showed, you could just inject before into your REST endpoint. And all you would need to do this in parallel is basically submit 1 job, submit another job, so future 1 and future 2, and then to get those merged back together, then you could use your future 1 get, future 2 get, and then you're done. Okay, and as I say, both of those threads would be spawned and carry all the context that you require to do everything you need to do in a Jakarta Java world. So security, you'd be able to inject beans, you could look up inject EJBs, you could do JPA and using all those sort of things you could do in these submitted jobs. So concurrency is pretty fundamental to be able to build applications like this. And another aspect of Jakarta Concurrency is basically running scheduled tasks. So if you wanted to, for example, again, have a REST endpoint that wanted to kick off a periodic task, then Jakarta Concurrency provides the equivalent of the Java SE scheduled executor service. So you could basically kick off a job to periodically poll something, or run a managed job at some period in the future, and you can do that again with the same security context and things as the original REST endpoint, and the same ability to inject all the services you need. Before Jakarta Concurrency came along, you could only do this with EJB timers. So in Java 5, well, EJB 3, you can basically put a schedule on an EJB timer, and that will achieve the same sort of thing. And you'd have to use programmatic timers and those things. So, but what this allows you to do is you can actually now do this for CDI beams and other components within Java EE. You could start, you could kick off tasks at deployment time with a singleton EJB or something like that, or a startup CDI component. So fundamentally, Jakarta Concurrency just provides you with these abilities from the Java SE API and provides you the way to do it within the application server and with the right context for the application server. So that's the use cases. So what we're going to look at is very briefly really is what are the main components of the API, and how are they used, and how are they used to integrate with other frameworks which may not be natively usable within Java EE because they use Java SE primitives. So from the executive services point of view, Jakarta EE provides two basic concepts, and they map directly across to the equivalent Java SE concept. So we have a managed executor service. This effectively maps across to the Java SE executor service. So you can submit jobs to it. They run in the context, they run in a thread pool, and they run in the context of the application that submitted the job, if that's what you want to do. And within Jakarta EE, you can configure additional executor services. So if you want to manage your concurrency with different thread pools, different groups of executors, then you can configure them. But currently, the API only allows you to configure them through the administration of the application server. For example, in Payara, you have to do it through the administration console. However, it does provide you a default one. So you can look up the default one and you can inject a default executor service. The other one it provides is a scheduled executor service. So that just basically allows you to run things on a schedule. So you can submit a job to be run at a future date, or a future time, or on a period. And again, that maps exactly API-wise to the scheduled executor service in Java SE. There's a couple of enhancements to it. The first is a managed task listener. So you can basically add a callback interface when you submit a job and get told whether the job's been aborted, completed, those sort of things. And it also provides a trigger interface. So this is an API which allows you, when you submit the job, to basically this executor service will call back to your trigger to ask if the job is ready to run. So you can build essentially whatever complicated schedules you would need to do if you needed some complex business logic to decide whether to run a job or not. You can use the trigger interface to do that. And again, you would just submit the job to a scheduled executor service and provide a trigger interface. Then they're basically the two main components that you would use in your application if you were in the pure Java EE Jakarta world. There are some other components which are basically used to interface this API with maybe APIs that aren't designed for Java EE. So one of them is the managed thread factory. So this basically mimics a thread factory in Java SE. So if you have a library that you need to use that basically uses thread factories to spawn threads to do things, perhaps it's like a video processing library or something like that, but you need it to be running well in a Jakarta EE runtime in the correct context and things, then basically Jakarta EE concurrency for Jakarta Concurrency provides a managed thread factory. And you can use that to basically integrate into that library if it provided you with an interface to plug in a thread factory. So here's an example. So this again, it's a REST endpoint, but that doesn't really matter. What you can see is that you can inject a managed thread factory. The runtime will provide you one by default. And in this code here, what I've got is standard Java SE code. So you would basically do executors, new fixed thread pool, and then you pass it in a thread factory. So if you've got an API that spawns these thread pools like that, and that knows nothing about Java EE, and it gives you an opportunity to provide the thread factory, then you can push a managed thread factory in there. And then every job that would be submitted onto that thread factory, onto that executor will be on a managed thread. And again, what I mean by managed is that it has all the context of the caller. It has all the required context to set up CDI injection and all those other things. Because if you try to do that on a raw thread, it's just going to fail. So that's the managed thread factory. That's there to provide, as I say, an alternative for a normal thread factory, so it's kind of managed. The next thing we have is if you can't get a thread factory, basically you can use something called the context service. Again, it's another API for more advanced use cases where you need to integrate with another library that's totally unaware of Jakarta EE. So what this does, this allows you to wrap any runnable in a context. Okay, so again, so to provide a security context or to use CDI components or things like that. So to use this, so for example, if you've got an API that only takes a runnable and it's going to spawn its own threads and do whatever, then you need this context service. So for in this example, so what you do, you just inject a context service, or you can look one up on J&J if you need to. And then say you have an API that's just going to take, it's just going to spawn a thread and it just wants a runnable. So we have a runnable here. Okay, so what you would do is you use the context service. You do call an API called create contextual proxy. And what that does is it takes your instance, so any random runnable that you have, and it wraps it in a proxy. And then you can submit that proxy runnable onto the random thread that you've had spawned. Okay, and what this basically context service is doing is it's creating a proxy for your runnable class, and that proxy will set up all the correct contexts for running that code within a Jakarta EE runtime again. So it'll provide security propagation, all the context to do dependency injection and all those things. So that's basically Jakarta Concurrency API. It's actually a very, very simple, small API. It's used, as I say, to integrate with standard Java SE concurrency and provide you all the power of standard Java SE concurrency, but within the correct context for running your Jakarta application. So now I'm going to look at features. So what I've covered is basically the state of the API as of now. So essentially it's those executor services, and then it's some APIs to integrate with normal Java SE threads to provide you that context. So where we are now, we're starting to develop Jakarta E10. As we said, Jakarta E10 we will need to release sometime in the beginning of next year. So we have an opportunity now to evolve this API, and this is where we're looking for assistance and help and just ideas. And if you want to get involved in Jakarta EE and shape these APIs, then you're absolutely welcome. So I'm going to basically cover some ideas.
Steve?
Yeah.
There is a question. Can we ask question right now?
Yeah, sure. Go ahead.
Because the context is changing. Can we? I am also writing into chat to you. If you can. Just a moment.
See the chat. Okay.
It is Selimjan is asking. Can we spawn threads across multiple JVMs with Jakarta Concurrency? JMS can do that.
No, obviously, if you need to send messages across JVMs, then Jakarta Concurrency won't do that. You would need JMS to do that. It's an interesting thought, though, because maybe it's possible to do it. But currently in the API, no, it's just going to spawn a thread locally.
Okay, thank you. There is no question. There is no question more.
Okay,
thank you.
So futures. These are some of the things that are ideas. When I come to get involved, I can point out where these are online, so you can contribute. The first one is deployable managed objects, so managed executors, for instance. As I said, currently you get a default managed executor, so it's just effectively a default thread pool. To manage that or configure it, you'd have to use an application server's administration consoles. So one of the things that isn't in the API now, but we'd like to add, is basically the ability to deploy these like you can nowadays in modern Java EE, Jakarta EE, like a data source you can now deploy using annotations. What we're suggesting is if your application wants to create its own executors, then we would have a deployable annotation. So for example, this is just purely ideas. So we have an executor definition that you could add to your components, and you could set the thread pool max concurrency, the minimum concurrency, its JNDI name, etc. And that would allow you, if you really wanted to create a highly tuned system with different things executing in different thread pools so they don't get clashes or don't lock or deadlock, then this would be the way to basically manage thread pool definitions and creation in the same way as you would do it in Java SE using the new executors static API. That's one. Another idea is a schedule annotation. So this would basically be like the EJB timer annotation, but you could add it on any component. So any servlet or an EJB, sorry, not EJB, a CDI bean, or anything like that. For example, here we have how that might look. So for example, if you had an application scoped CDI bean, then on any method, you could add a schedule annotation. And for example, this would tell it to run this, basically run this method every 5 minutes and run it on this specifically named executor service. So that would be a specific thread pool. And that would allow you to basically not have to use EJB timers, and you'd be able to put that on a servlet or a REST endpoint method or something like that. And we could extend that to have like cron-like commands, so you could set like a cron tab format or something like that. We could also support persistence, and potentially we could also support clusters and things. So actually you would have one schedule fired at one, only on one JVM within a cluster or something. So that's an idea for that. That could extend, basically, we could also use the trigger interface I mentioned to allow you to plug in a set of your own business rules of when the schedule would fire. So you could pass in the triggered class here or something. So that's another one. Another idea we're thinking about at the moment is a new async annotation. Basically, we have a lot of async annotations in Jakarta EE. We have them on servlets, we have them in REST, but then all of them are independent of each other. So what we'd like to do is actually unify all these annotations to work based on Jakarta concurrency. That isn't likely to happen in EE10 because that would need a lot of APIs to evolve. But I think that would allow us to, again, to unify the platform, make it more consistent, and you could use your own executors that you've used deployed through that annotation that I mentioned earlier. So that's one of the things we're considering at the moment as well. Another is Java util concurrent has moved forward quite a bit since in the first release of Jakarta Concurrency. We need to bring Jakarta Concurrency back into alignment with Java SE. That means we need to do work to support the fork join pool so that we could create managed fork join pools. It is possible to do some work, like for example using the Thread Factory APIs to get some of this already, but it'd be good to be standard and not have you as a developer not have to do anything. So we could have a managed fork join pool, and that would allow you, to use all the standard capabilities of Java SE, but in a managed way. And again, that would be supporting the Flow API that was in Java 9, and we'd probably be aligning this with Java 17. And again, completable features come in since Jakarta Concurrency, and that needs to be added into the API. We probably need something like managed computable future, or basically add and support the APIs that are developed in Java SE. I mentioned briefly MicroProfile. One of the other things that was done in MicroProfile is that actually the Jakarta Concurrency, because we were doing all this migration to Eclipse Foundation, was stalled for a while. That MicroProfile was where a lot of innovation happened, and they introduced a new API called context propagation. And that effectively, this is basically the text here, the definition from that API. That essentially has done some of the work around completable futures and integrating Jakarta Concurrency with CDI. What we're going to do is look to migrate a lot of that API work from MicroProfile back into the Jakarta world. And that will solve some of the things around Java SE alignment, and it has some additional capabilities which we'll look at to unify in Jakarta Concurrency. And then, as I mentioned, there's a lot of work needed to do on platform alignment. So again, how we work with CDI and MicroProfile context propagation has done a lot of that work. One of the things that actually came through yesterday or sometime early this week is, for some strange reason in the past, Jakarta Concurrency wasn't available in the web profile. But given that it's just fundamentally about threading, that was a bit weird. So we just got agreement to extend the web profile to add in Jakarta Concurrency. So that's good. So that will now be in the web profile. Again, as I mentioned, we could re-implement enterprise beans asynchronous, we could re-implement EJB timers on this API, and we could re-implement async servlets and JAX RS onto this API. And what that would do is give us consistency across the platform. And if we have that deployment of managed executors, then that would give us a way more or use a developer a better way of defining what thread pools you want and which thread pools these asynchronous APIs would run on. And that would allow you to do very fine-grained tuning if you're in really high performance situations where you need to be careful about how many threads are running which jobs. Then there's a whole load of internal cleanup and evolution that we need to do. Java SE 8 had date time support, and because Jakarta Concurrency is actually predates Java SE 8 because it came in Java EE 7, and then we have no date and time support in the trigger APIs and some of the other APIs around scheduling. So that is a small piece of work that needs doing. As I mentioned, there's this class called a trigger, and what that does, it's just an interface that you submit for when you do a scheduled job. And what it does is it asks, basically the scheduler asks the trigger class whether the job can be run. And that's a very useful API, but there's no concrete implementations of it provided in Jakarta Concurrency. So there's some obvious things we could do. For example, we could have a cron trigger. Spring has this, so that you could, say, provide cron schedules, and we could create some other ones as well. Just that way useful for developers so they don't have to go and create their own. And then there's a whole bunch of configuration attributes to your executives that are non-standard. So they are different for different application servers, so they're different from Payara, different from, say, OpenLiberty or JBoss or something like that. So we could do with standardizing some standard configuration attributes. So that's how our basic schedule of work, if you like, that we're trying to get done. But a lot of that involves on people helping out at the end of the day. I am normally the project lead, but that doesn't mean to say I do all the work. What it means is I try to encourage people to get involved. As I said, one of the big things about moving to the Eclipse Foundation is this is now an open source project on GitHub. So I'm basically going to have a couple of slides about getting involved before I finish up. First, what is a specification? Because this sort of links into where can you get involved. So part of the Jakarta EE and the Eclipse Foundation is and Jakarta EE in general, is that it's a specification. It's not just an API. And what I mean by that is it provides three things you need to release. One is the API jar, obviously, which is the one that you use as developers. But the other two things we need to create are a specification document. So this basically describes the API, how you use it, and provides sort of narrative information about why things are as they are and how they should be used and how the API should execute. Because the key difference between Jakarta EE, say for against something else like Spring, is that we produce specifications. Other people, there can be multiple implementations of Jakarta Concurrency. For example, Payara's implementation is different from JBoss's implementation. So the spec basically says how an implementation must implement these things. And then the final thing is a TCK, which is a technology compatibility kit. So it's basically a test suite that tests implementations and proves that they meet the specification and they behave how you'd expect them to behave. So this is used to basically validate that Payara, for example, implements Jakarta EE concurrency, or JBoss also implements Jakarta EE concurrency. And that's basically to provide you as developer portability. So if you had an application that uses these APIs and you move it from Payara to JBoss, or more preferably from JBoss to Payara, then you'd expect your application to run the same. So you can get involved in Jakarta EE in any of these bits or all the bits. So you could help write spec doc or modify the spec doc, or even if it's just typos you want to get involved in as a very simple first step. You can work in defining the API, for example, creating new managed executive definition annotations and how they should work. And as a developer, if you have strong views on what your API is that you want to use, you can get involved in that side. Or you could just get involved in improving the test suite, improving the coverage, improving compatibility testing. And you can get involved in any one of these areas or all of them. So how do you do it? Basically, everything is an Eclipse project. Okay, so you go along to this URL, or you just go to Eclipse and search for E for JCU. There's a mailing list, and that's where developers will hang out who are trying to developing these APIs. We're quite early at the minute, so there's not a lot of traffic, but that needs to ramp up to get it out for Jakarta E10. And then all the code is on GitHub. So a lot of the issues, the features that I described in these slides are basically single issues in GitHub. So if you have an opinion of how an API should look, or if you want changes to the API, you can raise an issue on the GitHub repository, and then it'll be basically discussed on GitHub and through the mailing list. And just like any open source project, you can make PRs and those sort of things. And then the other thing you need to release when you do release one of these specs is what's called a compatible implementation. So that is just any implementation that passes the TCK. Currently, we have our own in the same GitHub sort of project, which is the concurrency RI. And that one's used, that's the implementation that's used in GlassFish or in Payara. So you can get involved in that as well. So, for example, if we were playing with the API and trying to create a new async annotation, then we'd also have to show the implementation of that in the implementation project and show that it passed the TCK. So you need to write a TCK as well. So getting involved is no more difficult than getting involved in any open source project. And if you want assistance or anything, I'm happy for people to reach out to me or anyone on the mailing list. And if you want to be pointed at anything that you'd like to contribute to. Okay. So that's all I had. Hopefully that's of interest. So thank you for listening to me. And that's it. Any more questions?
Yeah, thank you, Steve. And there is a question from Habib Hakan. He asks, Brian Gott said that the project Loom is going to kill reactive programming. Will you have an implementation plan for the Jakarta EE concurrency specification with the project Loom?
We don't have a plan because Project Loom isn't appeared in any Java SE version yet. However, from my understanding of Loom, is that it will be using standard thread primitives in Java from Java SE. So it'll just be, when you create a thread factory, you'll provide a parameter which says whether you want lightweight threads or not, or full threads, or whatever they're called now in Loom. So I imagine that it's going to be very trivial for us to integrate and create Loom threads or lightweight threads or whatever they're called through Jakarta Concurrency. So I expect that absolutely to use Loom very rapidly after Loom comes into an SE version. And we could start, like I say, we could start defining the API now on GitHub if we wanted to, as part of the experimentation within the open source. I sort of agree with Brian that it's going to kill reactive programming in some ways. Obviously, people who really love reactive will probably stay on reactive, but for average people who, not average, because that sort of denigrates a developer, but developers that aren't that interested in doing these complicated APIs, who just want to use standard threading APIs, they're going to get massive benefit from it, and therefore, I think the challenge of learning reactive, it will not be worth it for most people who just want to build their applications and not get into the ins and outs of reactive.
Yeah.
Okay.
There are no more questions right now. And thank you, Steve. It was a very informative presentation, and we have some very, very much notes on that. And thank you, Selimcan and Habib, for asking good questions. Selimcan also thanks to you in the question area. So if there are any questions, no question. Yeah. I think that's okay.
Okay.
Yeah. Thank you for joining us, Steve, again. And
no problem, anytime.
Yeah. Thanks for the audience for listening us. Hope to see you in next events. Goodbye.
Right, thanks.